When forecasting severe weather, there's more happening in the atmosphere than meets the eye. Meteorologists rely on key ingredients to predict when storms could turn severe.
Meteorologist Blake Hansen explains what those ingredients are and how they play a role in the forecast.
Forecasting the weather is complex, as the atmosphere is always in constant motion. This complexity is enhanced when severe weather is a possibility. Of the roughly 100,000 thunderstorms that occur each year in the United States, only 10% become severe. So what goes into forecasting severe weather? Let's explain. There are 4 common ingredients that can enhance an ordinary thunderstorm into a severe one: moisture, lift, instability, and wind shear. Let's start with moisture. Thunderstorms need enough water vapor to form clouds and induce precipitation. We measure moisture through the dew point. The higher the dew point, the greater amount of moisture present in our atmosphere. Next is lift. Air needs a push upwards to start thunderstorm formation. The most common source of lift is through a front, but it can also occur simply through the heating of the day. In West Michigan, we have a unique mechanism of lift. It's known as the lake breeze. Simply, lift gets things going. Our third ingredient, instability, and it works hand in hand with lift. Instability determines how fast the air rises once it is lifted, a measure of energy in the atmosphere. The more unstable the air, the faster it rises, fueling strong updrafts that power severe storms. Our last ingredient, wind shear. It's a change of the speed or direction of wind with height, and it enhances storm strength and organization. Speed shear happens when winds get faster the higher you go. It tilts a thunderstorm, helping it grow taller and last longer by separating the updraft and downdraft of an individual thunderstorm. Directional shear is when winds change with height. This can make a storm rotate, and this is a key factor when looking for tornadic activity. So of these 4 ingredients, they vary with each storm, but can be analyzed by observing current conditions or predicted using forecast models. Meteorologists examine the atmosphere from top to bottom, starting with the jet stream, then working downward through mid-level winds, pressure, and vorticity before focusing on surface conditions like fronts, temperature, and precipitation. A sounding is a forecast tool that provides a vertical snapshot of the atmosphere, helping meteorologists understand weather conditions at different heights. It's gathered in real time from weather balloons or predicted through models. All of this allows meteorologists to determine any source of moisture, mechanism of lift, magnitude of instability, and amount of wind shear, then utilize it all into a simplified forecast. Understanding the 4 ingredients highlights just how complex and ever-changing the atmosphere can be, which is why it's so important to remain weather aware and prepared for whatever conditions may develop.
Great information, Blake. Thank you.